any user can add a new record into a table, that is one operation, and he can delete a particular record in a database, that is another operation. Or union, yes, we should display all the records of both the tables without any duplication. So this is union operation. The intersection of R and S is a relation that includes all the tuples that are both in R and S table. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Friends, let us continue our discussion with the topic Relational Algebra. What is Relational Algebra? Say you might have studied Boolean Algebra. What is Boolean Algebra? It deals with binary numbers 0s and 1, which stands for false and true. So we are dealing with binary numbers. So here relational algebra, are uniquely defined using relational algebra, and it is the formal description of how relational database operates. So this is nothing but we are going to decide the operations on database. That is nothing but relational algebra. So here it is an interface to the data stored in a database itself. So now data is stored in a database, and we are here DBMS, Database Management System, is a software. It is an interface between the database and the user. That is a definition what you have learned at the beginning. So here we are going to work with the database through DBMS, and in that too with operation or nothing but operators. So this is nothing but relational algebra and the mathematical which underpin SQL expression or operation. So this SQL expressions or SQL queries is based on this relational algebra. So generally relational algebra is used to work with the database and different operations. So this is relational algebra. Now let us talk about operators. So here if we talk about operators, and you know what are operators and what is an operation. Now with respect to database, here what type of operations we can expect from the user. So here one is in a database, it is made up of number of tables, and each table is made up of number of columns. So here any user can add a new record into a table, that is one operation, and he can delete a particular record in a database, that is another operation. Similarly, suppose if you want to display or you can have a view of different views on a database, that is one operation. And suppose I want to modify the database structure, that is another operation. Similarly, I want to update the values in a database with respect to number of records or number of columns. So all these are different operations can be performed on database. That is what we are learning under relational algebra and under the heading operators and different operators which works with different operations on database. Now let us start with one is write operations or writing a record into the data. So here one is insert operation. So what is insert operator or operation? It provides a list of attributes values for a new tuple in a relation. So tuple is nothing but a record. So in other words, we can say insert operator is used to insert a new record into a database. That is insert. Next one is delete. What is a delete? It provides a condition on attributes of a relation. Relation is nothing but a table, and determine which tuple to remove from the relation. So delete operation is used to remove a particular record based on the condition of particular column or particular attributes. So a record can be deleted, removed from the database with delete operator. Next one is modify operator. So what is modify? Modify is nothing but changes the values of one or more attributes in one or more record is nothing but modification. Modify the values or update the values in a table with respect to maybe with more than one columns or more than one attributes or more than one record. So this is modify operator. So this is write operators. Now let us move on to next slide. And next one is operators for retrieval operators. Retrieval is nothing but to view. We can have different types of views by using retrieval, or we can retrieve the data as per our condition with respect to certain conditions of particular columns. So here under this we have a mathematical set theory based relationship. So they are union, intersection, differences, and Cartesian product. These are the different types of operators to retrieve the data in a table or in a relation. This is retrieval operators. Next one is another special database operators. They call select, project, and join. These are different operators. Now what relational select? So let us see the definition of select operator. It is used to obtain a subset of a tuple of a relation satisfied select condition. Suppose, what is the meaning of subset of a tuple or a record? Suppose in a record, if I have around 10 columns. So here I would like to display, or I would like to select only 5 columns out of 10 columns or 10 attributes in a record. In that case, I can make use of select command. It is used to obtain the subset of a record. Same example. Suppose if there are 10 columns, attributes in one record or number of records, I can display only 3 attributes or 3 columns based on certain condition. So that is nothing but select operator. For example, select employee ID equal to 100 from the table employee. This is the table name, employee is a table name, is the operator, and this is the condition. So what is the condition here? Employee ID equals to 100. So if there are more number of employees and with the different employees ID, with the help of this command, I can display those records with employee ID equals to 100. So this is retrieval operator select. Let us move on to next slide. Next one is called a project, relational project operator. So it is used to select a subset of attributes of a relation by specifying name of the required attributes. So this is again to select the subset of an attribute. Example, to get list of all employees with surname and employees numbers. So here, suppose I would like to have a set or a subset of a table. Here I would like to display the surnames and employee numbers of all the employees. So here I am going to select 2 columns or 2 attributes. So that is a project operator. Example, project employee name, address of the table employee. Here project is an operator and employee is a table. Under that I would like to display employee name as well as address. So it is going to select or is going to retrieve only 2 attributes with employee name as well as address in a relation or in a table. So this is project operator. Now next one is set operators. Here one is union. This is union. So consider 2 relations R and S. Now look at the example here. This is one table, it is R, another table S. So this is set operations or set operators. One is union of R and S. Union of 2 relation is a relation that includes all the tuples that are either in R or in S and in both R and S. Duplicate tuples are eliminated. So this is one operation called union operation. It requires there are 2 tables or 2 relations. So here it is going to display all the records of both the tables without any duplication. That is union operator. Look at the example, R table and S table, R union S. This is R union S. It should display all the records of both the tables without any duplication. So this is union operation or union operator. This is how it works. So it's going to display all the records of both the tables without any duplication. This is union operator. Next one is intersection operator. So intersection of R and S. The intersection of R and S is a relation that includes all the tuples that are both in R and S table. Again, there are two tables. It's going to display where the common records are present in both R and S. So this is one R table with number of records, another S table with records. So R intersection S means in this one, A1 is a record is common in both the records, so both the tables. Similarly, D3. So this is one A1, and here A1, D3. These two are common in both the tables. So those it retrieves this common records in both the tables. It is called intersection operation. This is R intersection yes. Now let us go to next slide. Next one is difference. So difference operation. So here difference of R and S. This is the relation that contains all the tuples that are in R but not in S. Differences, the definition is that contains all the tuples, means records of R and which are not in S. Look at the example now. R table and S table. So here differences, this is R, difference yes. In this example, A1, F4 is here, F4 is not here, F4 is not present in this table. It display all the records which are in R. A1 is present, it display A1. And here F4 is here, F4 is not here, F4. And here E4, here E is there here, and here E is there, it display E5. So this is R difference, yes. Similarly, it is also possible to have S difference R. Now we consider S record first, then table. Next one is R table. So S difference R is nothing but it consider all the records of S and again all the records of E. In this example, A1 is present, S is not there here, D, C2 is one here, and as well as E4. E4 is one example here. So S difference R, E4 is here, and which is present, not present here. So this is nothing but difference operation or difference operator. Next one is Cartesian product. So the Cartesian product is also an operator which works on two sets. It is sometimes called as cross product or cross join. These are the join operators. So cross product or cross join, another name of Cartesian product. It combines the tuples of one relation with all the tuples of another relation. Look at the definition here. It combines tuples of one relation with all the tuples of another relation. Now let us see the example for this. Here in this there are two tables. One is R, second one is S. So after the definition, it contains tuples of one relation with all the tuples of another relation. For example, this is R. A1 is present here and S is A1. So A1 and A1 is the first result. So this is R cross S means Cartesian product. So next one is A1 with second record is C2. This is C2. Similarly, A1 with D3 and again A1 with E4. It goes like this. So this is the cross product. After this A1 with all the records are over, next one is start with B2. B2 with one record A1, B2 with A1 and again B2, this is B2 with C2. It goes on like this. So this is nothing but R cross S or Cartesian product of R and S. So this is the definition is it combines tuples of one relation with all the tuples of another relation. So this is cross Cartesian product or cross product of R and S. Now let us see another operators, join operators. join operator is going to combine the records of both the tables. Next one is, as the join becomes more complex, tuples are removed within the cross product to make the result of a join more meaningful. So this is another feature of join operator, and it allows you to evaluate a join condition between the attributes of relations on which the join is undertaken. So we can have a condition on different attributes or different column. Based on that, we can use join operator. Now let us see, for example, now here is join operator or join yes. So this is or join yes. So this join condition, this is a syntax, join condition, join condition. Now for example, this is or table, yes table. So this is column A and this is column B. This is column A and column B. So now for example, or join yes, the condition or column of A means R is the table, under that column A must be equals to S is the another table with the column A. So what is the meaning of this? So condition is that is going to retrieve the records where you should satisfy this condition. What is the condition here? The column A of our table must be equals to column A of S table. In that way, look at the product now, look at the result. So A1 is here and this is A1. So this is column A and A is here. So this is A1 and A1. Next one is B3, and here if you look at the example here, B3 and D3. So here D3 is here and D3 is here. So it takes out D3 and D3 and column B, this is B. B3, B3. Next one is E5, E4. Look at this E. Column A is E here and column A is here. Column A of B is here, is going to display E5 as well as E4. So this is the condition of or join yes based on this condition. Now similarly, if you look into second example, or join yes, the condition, this is a condition. Here column B of R must be equals to column B of yes. If you look at the table here, column B of R must be equal to column B of yes table. If you look into the example here, first one is A1. This is 1, this is 1. So A1 and A1. So this is column is going to match with this 1, 1 here. Next one is 2 and 2. This is matching with this column here. This value you should display through the data. This is B2 as well as C2. Next one is look at 3 and here value is 3. So this 3 is D3 and D3. D3, D3. This is going to display or retrieve this record also. Next one is in the column 4 is here, 4 is here. It is F4 and it is E4. It is E4 and E4. This is the result of or join yes. Condition is column B of one table must be equal to column B of another table. So this is join operator. Students, let us continue my discussion in our next session. Thank you very much.